Good afternoon, students. In the previous class, we were discussing about the Border Gateway Protocol, and we have gone through the RIP and OSPF protocol. Okay, where this comes under the hierarchical routing. So we have gone through all this route initiation protocol, open shortest path forwarding, and Border Gateway Protocol. So today we'll discuss about the broadcast routing. Okay, so what's the general meaning of the broadcast routing? So we know that the broadcasting is nothing but just sending a message to all the people that is there in the network. Okay, when we enter the classroom is example. So if a teacher enter the classroom, so if she start teaching, so it should be audible to everyone. Okay, that is just broadcasting. Okay, for example, even radio. So radio, it is nothing but it's an example of broadcasting. Okay, or TV broadcasting. So the broadcasting in the sense sending message to all the people that is present in the network. Okay, delivering the talk to all the people that is there in the classroom. So that is nothing but the broadcasting. Okay, so the broadcast routing, in the broadcast routing, so deliver the packets from source to all the other nodes that is existing in the network. Okay, so but here there is one issue with respect to broadcast routing. So the issue is the duplication of the packet, the duplication of the packet. So now let us consider there are four routers here in this particular network: R1, R2, R3, and R4. Okay, so here what happens in the first symbol, we can see that there is a duplication of the packet. So R1 is going to deliver a packet here. Here you can see a black arrow mark. Look into this laser. So here you can see at the center you have a black arrow mark. So R1 has delivered a packet to R2. Now the R1, since there is two more routers R3 and R4, so in order to deliver the same packet, what it's going to do, it's going to create a duplication of the same packet. So the same packet, so if you send R1 to R2, R2 will take the responsibility and it has to deliver the packet to R3 and R4. But R1, what it's going to do, again, since it has to deliver the same packet to two routers R3 and R4, what it's going to do, it's going to create two more duplicate packets, okay, and that will be delivered to R3 and R4 through R2. So this is what called as the duplication. So the duplication of packets has been done at the source end itself. The source itself, it's going to create a duplicate of packets, and then that duplicate packets means the packets creating again and again, the same packet creating again and again, that one you're going to call it as the duplication of packets. Okay, now here you can see. So R1 has delivered the packet to R2 here. Okay, so now R2, it is going to create two more packets and that will be delivered through R3 and R4. Okay, one thing is R1 will be delivering the packet to R3 and R4 through R2. And again, whichever the packet the R2 it has received from R1, so again it is going to create two more duplicate packets and that will be delivered to R3 and R4. So here through R1, two packets again it has been created and it has been sent to R3 and R4. Here whatever the packet that it has, same packet that it has received from R1, and again the same packet will be delivered to R3 and R4. So here again a duplication of packet will be created. Okay, so while doing the broadcasting, while sending the package through broadcasting, so what happens is, so at the source itself or in the network itself, the duplication of the packet is going to occur. Okay, so for creation of the packet, so much of energy will be wasted, so much of network resources will be wasted, the infrastructure will be wasted, bandwidth will be wasted, channel reserve will be wasted. So there will be so much of wastage in the network resources or in the network infrastructure. Okay, so here the source duplication. How does source determine recipient address? How does the source determines the recipient address? We'll see how the source will able to determine the recipient address. So here we have seen. So suppose if we go for the broadcast routing. So here the duplication of the packets occur. The duplication of the packets occur at the source or in the network. Okay. So here this has to be avoided. So this broadcasting duplication of packets in the broadcasting to be avoided. So in the network there will be duplication. This duplication should be avoided. Okay, and so we'll see how this duplication actually is going to occur. So there is a concept called as flooding. Flooding. So we know that the general meaning of flooding is nothing but overflow of water from the rivers or the seas. So that one you're going to call it as the flooding. Okay. When a node receives broadcast packet, sends a copy of to all neighbors. So what happens here itself? You have seen a simple example. Here you have seen R1 is going to send a packet to R2. The same packet, since two more routers are there, again it is going to create two more duplication of packets, and then it's going to send it to R3 and R4. Okay, like this, suppose if a complete network is there, so this type of duplication will be happening. Same packet will be keep on creating again and again, and sending the same packets to the different same routers again and again by different routers. So that is called as flooding. Flooding is nothing but sending the same packet, sending again and again by different routers to the same sender again and again. So that is called as flooding. So due to flooding, the cycles will be, and also the problems existing in flooding is nothing but cycles. So cycles exist. Okay, means the same packet delivered to the same sender, same receiver again and again. And broadcast storm is nothing but, so due to the more flooding of this. More flooding of packets, a storm will be created. A storm will be created. Okay, so this is the broadcast storm. It is nothing but, so the broadcast radiation, that is the accumulation of broadcast and multicast traffic on a computer network. So broadcast storm is nothing but the accumulation of this broadcast and the multicast traffic, that is called as the broadcast storm. Means accumulation of a set same packets across the network. Okay, so there will be more number of repetitions, more number of cycles will be there, more number of packets you are sending again and again to the same receiver. So that is called as the broadcast storm. Or simply we can say that the broadcast radiation. So what it's going to do, the broadcast radiation, it is going to accumulate, or is the accumulation of the broadcast and the multicast traffic on a computer network. So that is called as the broadcast storm. Okay. So due to this flooding, the cycles may occur, or the broadcast storm is going to occur. So broadcast storm, it's nothing but a broadcast radiation. This is the accumulation of the broadcast and the multicast traffic. Traffic is nothing but multiple number of packets that will be congested or accumulated at one particular point. So on the computer network, that is called as the broadcast traffic. Okay, so that is nothing but the broadcast storm. So how we can control the flooding? So we have to control this duplication or this flooding or the cycles or the broadcast storm. So how we can control this? Okay, so here so how to control this flooding? Suppose node only broadcast packet if it has not broadcast the same packet before. So while you're broadcasting a packet, you're going to check that if the particular packet is delivered and the same packet should not reach the same receiver again. Okay, that one we have to look into it. So we have to say that while broadcasting a packet, the same packet should not be delivered to the same receiver again or the same host again. So that one we have to take care. So how we can do this? Okay, so here we can do with the two things. So first thing is we can keep track of the packet ID. So what we have to do is for each and every packet, whatever you're going to deliver, you have to attach a sequence number or a packet ID. Okay, if that packet ID, when it reaches the host or when it reaches a node, the node has to check whether the packet with this particular ID is existing or not. So it has to maintain a register. In that register, it has to keep track of which are all the packets that it has entered the network. Okay, so whichever the packet ID doesn't exist, then only the packet should be accepted by the host, or else the packet has to be dropped. Okay, that's how. That is one method where we're making use of the packet ID. So you can able to broadcast, okay, and you can able to drop the packets if it is already existing. Okay, and second thing is reverse path forwarding. Second is the reverse path forwarding. Only forward the packet if it is arrived on shortest path between node and the source. Okay, suppose if there is a shortest path between the source and the node, only if there is a shortest path exists through that path, so the packet has to be received, or else the packet has to be send it back. Send back to that particular source from where you have received. If already the path exists already, the packet has received. So reverse path forwarding, what it says is only forward the packet if it is arrived on the shortest path between node and the source. So if there is a shortest path and if it has arrived through that path, then only you have to accept the packet, or else you have to reject, or else you have to send back. If you reject the packet, then it will go and reach the source. So that's why it is called as reverse path forwarding. Accept only the packet that arrives on the shortest path, or else you have to send it back. Reject and send it back to the source. So that's why it is called as the reverse path forwarding. And spanning tree. So no redundant packets received by any node. So the spanning tree is nothing but, so where we are going to apply in order to avoid the duplication. So one more thing is the spanning tree. The spanning tree is nothing but covering all the nodes in the network. So spanning tree is nothing but a tree which consists of all the nodes in the network. Okay, and the minimum spanning tree is nothing but, so a spanning tree is one which is going to cover all the nodes, but with the least cost. So that is called as the minimum cost spanning tree or minimum spanning tree. Okay, so now, so spanning tree. First construct a spanning tree. So spanning tree, how we can construct the spanning tree is nothing but, so nodes and then forward and make copies only along the spanning. Okay, the spanning tree is nothing but, so where a tree which consists of all the nodes, where it is going to cover, and it should be with the shortest path. So here the spanning tree, what it says is spanning tree is nothing but a tree which consists of all the nodes that is covered, and the cost should be the least cost. So that's why it is called as the minimum spanning tree. So now the broadcast is initiated at A. So here you can see thick dark lines and the thin lines. Okay, the thick dark lines indicates, so these are all the path that the packets has to be transmitted, and this path we are going to call it as the shortest path. Okay, so now the broadcast is initiated at node A. So from node A, the broadcasting is going to start. From node A, the broadcasting will be started. See, from A to C, C to E, and E to F. But F to E, there is a path, but this is not the shortest path or the least cost path. Okay, we have to see in such a way that you have to cover all the nodes in a network or a tree with all the nodes existing in the network. Okay, a spanning tree which has all the nodes covered with the minimum possible number of edges or with the minimum cost. So that we are going to call it as the least cost path. So we have to cover all the nodes. We have to cover all the nodes, and we have to see that the shortest path exists. Okay, with the shortest path you have to cover all the nodes. So this is not, see, F to E or E to F or E to D or D to E or C to B or B to C. Okay, this path, this exists, but it doesn't comes under the shortest path. All the nodes are reachable, but with the minimum cost. Okay, so now through A, if it broadcasts, it will broadcast like this: A to C, A to B, C to F, C to E, and then see here, A to B, B to D, and D to G. So all the nodes is covered A, B, C, D, E, F, G. But the thin lines, whatever that exists, so this indicates the path exists, but we have not chosen this path. Okay. Suppose if the broadcast is initiated at D, so how the packet will be traversed? So D to G, D to B, B to A to C, C to E, and E to F. Okay, this is also the spanning tree. Okay, spanning tree, it is nothing but you have to cover all the nodes in the network with the shortest path. So that is called as the spanning tree or the minimum spanning tree or the least cost. Okay, and then so there is one more method for the creation of spanning tree. So that is through center node. So we have to identify a node in such a way that it should be centered in the network. Okay, identify a node which should be centered in the network, and from that node it should be reachable to all. For example, if we consider A cannot be center node. If we consider G cannot be center node. Suppose if we consider F cannot be center node. You can also consider C. So C to A it is possible, C to F, C to E, C to B, B to D, and D to G. So like that we can construct. So choose a node which is called a center node where all the nodes should be reachable from that particular center node. Okay, here we have a stepwise construction of the spanning tree from the center node called as E. Okay, so now from the center node E will start. So the first, so here in the B we can see the construction of the spanning tree, and here we can see the count, the first path that exists between E and F, and second path we have chosen D to B and D to E. Okay, and the third path it is B to A. Okay, and fourth path it is C to E. Fifth path it is D to G. So like that here we are constructing this spanning tree. So where all the nodes should be covered, and we have to start from the center node. Okay, each node sends unicast join message to center node. So all the nodes that is existing in the network, it is going to send a message to the center node so that it needs to join to the center node E. Okay, then message will be forwarded until it arrives at a node already belonging to the spanning tree. So we have to see that where all the nodes should be reachable and in such a way that all the nodes has to be covered and it belongs to the spanning tree. Then only we can say that the spanning tree that has been created through the center node. Okay, so next, multicast routing. So we know unicast, you know broadcast, and you know multicast. So what do you mean by unicast? So sending a packet to one particular person in the group, to one particular node in the group, that is called as unicast. Broadcast means sending the packet to all the people that is present in the group. Okay, so example is delivering a talk by a teacher to all the students that is there in the classroom. Okay, and then multicast is nothing but sending a message or a packet to a set of people in the group or a group of people in the classroom. For example, there is 4 divisions of the benches has been arranged for the students. Okay, and whatever the message I am going to deliver, it should be delivered to only the first 2 set of people who is present in the first row and the second row. But it should not be delivered to the other people who is not a part of that particular group. Okay, that is called as the multicasting, means sending or delivering a message to a group of people that is existing in the network, only to some set. So in a set, if we have a subset, only to the subset of people the message has to be delivered, not to all the people that is existing in the network. Okay, find a tree or trees connecting routers having local multicast group members. Find a tree or trees connecting the routers having local multicast group members. So what is the main goal of this multicast routing? Find a tree connecting the routers having the local multicast group members. Means you have to find a tree in such a way that that tree should be connecting to a group of people where you have to deliver the message. Okay, so here a tree is nothing but not all the paths between the routers used. So a tree in the sense there is no need of considering all the paths between the routers. Only the router should exist. So here you can see. So here there is a diagrammatical representation. Okay, and then here you have a concept called a shared tree. Means the same tree used by all group members. So shared tree is nothing but the same tree that is used by all the group members. Then that is called a shared tree. So in the sense, the router, the path, or whatever the systems that is existing, it should be shared by all the group members. Then that is called as the shared tree. Okay, so a tree is just a combination of the routers as well as paths, but not all the paths. So that is called as tree. Okay, here there is a diagrammatic representation of the shared tree, where red indicates the group member, and this black indicates a not group member, and this red router indicates a router with a group member, and router, this white router, this indicates a router without a group member. Okay, here you can see the red, whatever the dark thick line that is indicated here. So this is a message that has to be delivered to a group of people to only through this path. Okay, only through this particular routers you have to deliver the packet. So here you have one group, and here you have second group, and here you have third group, and here you have fourth group. So for this 4 members in the group, you have to deliver the packet. So this is a complete network. Okay, how many systems are there in this network? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 4, 6, 8, 10, 12. Okay, in this 12 members in the network, I need to deliver to a group of people, that is 4 members in this network. Only 4 members I need to deliver the message. So in order to deliver to this 4 members, I need to choose the router. This is one router, this is other router. So this is one more router, and this is one more router, and this is the router where it is going to connect these 2 routers. So that's why I need to consider this is not part of a group member, but still I have to deliver the message to other routers that belongs to group members. So I am going to make use of this router in order to deliver the packet. Okay, a shared tree is nothing but the same tree used by all the group members. Okay. So here you can see source-based tree. So what do you mean by source-based tree? Means the different trees will be constructed from each sender to the receiver. So here you can look into the diagram. So here you have one tree that is represented in the green arrow mark, and the other one in the magenta color. So here you can see the magenta color arrow mark. So this is one particular tree, and which is represented in the green color. So this is one particular tree. So 2 different types of source-based tree, you can look into it. Source-based tree, you can look into it. So what this indicates is, so this is one particular tree that is created by the source, and this is one particular tree that is created by the source. Okay, so 2 different trees will be constructed by the source in order to deliver the packet. So this is called as the source-based tree. Okay, so the approaches for building the multicast trees. So how we can build the multicast trees? So we have 2 approaches. One is said to be the source-based tree, and the second one is said to be the group shared tree. So source-based trees, how we can construct? So usually 1 tree per source. For each source is able to construct one particular tree. Each source is able to develop one particular tree. So one is the shortest path tree, and the other one is the reverse path forwarding. So using the shortest path tree method or reverse path forwarding method, you can construct the source based tree. And the other one is the group shared tree. Usually group uses 1 tree. Okay, at least minimum 1 tree will be there. Okay, so where that will be shared. So the minimal spanning and the center based trees. So these are the examples, or we can construct the group share tree. Okay. So now the shortest path tree. So how we can construct the shortest path tree? Shortest path tree. The shortest path tree can be constructed using the Dijkstra's algorithm. So what we have to do is we have to apply the Dijkstra's algorithm. Already we have gone through. So Dijkstra's algorithm, it is nothing but the link state algorithm. So that is called as the single source shortest path algorithm. So using the single source shortest path Dijkstra's algorithm, we can able to construct the shortest path tree. you can construct the shortest path tree. Okay, so this indicates, so this numbering indicates, so the link used for forwarding I indicates order link added by the algorithm. So how? Step by step. So this link will be added to this shortest path tree. So that is represented by this number. First R1 to R2, and then R1 to R4, and then R2 to R3, and then R2 to R6, and then R5 to R4 to R5, and R5 to R7. So like this dark thick red line indicates this is the shortest path, and the complete tree we are going to call it as the shortest path tree, where it is going to cover all the nodes that is required, that has to be delivered, for which the packet has to be delivered. So with the shortest path, or with the minimum cost. So by applying the Dijkstra's algorithm, we can construct the shortest path tree. Okay, and then reverse path forwarding. Okay, so what it relies on? It relies on the router's knowledge of unicast shortest path from it to sender. So there should be a unicast. Unicast means to a single node, and the shortest path should be existing. Okay, one important thing when we consider the reverse path forwarding. So if you're going to choose a path, or if you're going to choose a path, you have to choose a path which is said to be the unicast shortest path. Unicast in the sense choosing only one node while sending the packet, and it should be the shortest path. Okay, so what you have to do, you have to apply this simple forwarding behavior algorithm. Okay, so if multicast datagram received on incoming link on shortest path back to the center, what you have to do, then flood the datagram onto all outgoing links. Suppose if you have received the datagram, that is a multicast datagram, okay, through the incoming link where that is said to be the shortest path. Okay, then what you have to do, just you have to flood, just you have to deliver the packet to all the outgoing links. Okay, else ignore the datagram. Suppose if you not received through the shortest path, then you have to ignore the packet. Now we'll look into this example. Okay, so here there is totally 7 routers. According to this reverse path forwarding, so whenever the packet is delivered, so you have to receive the packet, and you have to see that you are in the shortest path. See, if a packet is delivered from R1, it can reach R2 directly, or it can reach through R4. Suppose if R1 send a packet to R2 directly, there is also one more path exists, that is through R4. So when again the packet is delivered through R4, what this R2 has to do, since already a packet has received from R1, so same packet it cannot be received. So what it has to do, it has to reject. So that is indicated by this gray line. So gray line with this symbol. So what this indicates? So this indicates a stopper for arrow. It indicates that it is a rejected packet, because already the packet has received. And again R2 is going to deliver the packet through R4, and R2 has delivered the packet to R6. Actually R2 is connected to R1, R4, R3 and R6. Since the same packet that it has received from R1, the same packet is delivered from R4. Since the same packet is delivered, okay, and already this is the shortest path between R2, okay, it is going to reject this. This is not the shortest path from R1 to R2. R1 to R2 it is directly connected, so no need of again a shortest path that is through R4. So that's why it is going to reject the packet from R4. That is indicated by this gray line stopper. Stopper for this arrow indicates rejection of the packet. And then, so while delivering the packet, it has to see that it should not deliver to the node from where it has received the packet. Actually, R2 can be delivered to R3, R6, R4 and R1. But since it has received the packet from R1, it should not send back the packet to the source again. So that is also one condition. One condition is it should be in the shortest path. Whichever the packet that you are receiving, so you are receiving the packet where it should be the shortest path. And second thing is, while delivering the packets or while flooding the packets from that particular node, it should not flood to the source from which it has received the packet. So R2 has received the packet from the source R1. So it cannot receive the packet from the source. So that's why it's going to deliver only to R3 and R6. To R4 also it is going to deliver, but R4, since there is a direct connection from R1 and same packet it is receiving from R2, it is going to reject here. Okay. Now R4, what it's going to do? R4 is connected to R5. Okay. To R5 it is going to send, and since R1 is a source, so it cannot send the packet here. So whichever the packet that is sent from R4 to R2, it is rejected already. Okay. Now R5. So R5 it can send to R6 and R7 and R4. But R4 is the source from which the packet has received. So what it's going to do? It is going to reject that. Means already it has received, so it cannot send it back. So it can send it to R7. R6 it is going to send, but already R6 has received the same packet from R2, and this is the shortest path. Since this is not the shortest path, so what it's going to do, it's going to reject that packet. It's going to send back a reverse to the R5 that I don't want this particular packet. And whatever the packet the R6 it has received from R2, it is going to deliver to R3 as well as R5. But in the shortest path, so this path doesn't exist between R6 and R5, and this path doesn't exist from R6 and R3. So that's why what it's going to do, the R5 as well as R6, both they are going to reject the packet. But R5, since it is connected to R7 it is not connected to anyone and there is no any duplication of packets, so it is going to receive the packet. So this is how the reverse path forwarding, through reverse path forwarding, your multicasting can be done. So router with attached group member. So as usual, so this red color router, it indicates the router with attached group member, and this blue color router with no attached group member. So it indicates the group members to which you have to multicast the packets. Okay, and red indicates datagram will be forwarded, and gray color with the stopper indicates datagram will not be forwarded, so it will be rejected. Okay, so that's why it is called as, it is rejected back to the source. So that's why it is called as reverse path forwarding. Okay, resultant is the source specific reverse shortest path tree. So at last, whatever you're going to get, so you're going to get the shortest path tree. Okay, maybe a bad choice with asymmetric links. So this is one method where we can able to identify a shortest, construct a shortest path tree with the concept called as reverse path forwarding. Okay, so reverse path forwarding, pruning. So pruning is nothing but cutting the bushes, stems apart from the main branch. So that is called as the pruning. So already the shortest path tree that has been constructed. So whichever the links that is not required, so that one you can cut it off. Okay, so the pruning general meaning is cut off the extra stems or the branches or the bushes. So that is called as pruning. So here also forwarding tree contains a subtrees with no multicast group members. So here some people who doesn't belong to the group. Okay, you'll be having the shortest path tree and you are going to cover the routers, but that routers that doesn't belong to the group. So at that time you have to prune that, you have to cut off those routers. Okay, so here this whatever the brown color arrow with P indicates the prune the messages. Okay, and the red indicates the links with the multicast forwarding. So here the red indicates the links with the multicast forwarding. But here there is a group of people, two set of routers where these routers they doesn't require the message from they doesn't require the message during the multicasting. So at that time you have to do the pruning. Pruning is nothing but, so whoever who is not in the group, they have to be cut off. They have to be removed. Okay, no need to forward the datagrams down the subtree. No need to forward the datagrams down the subtree. So no need to forward the datagrams down the subtree. So here at the down. So these tree means subtree doesn't require for R6 or R4 because R5 and R7 they doesn't belong to the group. Okay. Prune the message is sent upstream by router with no downstream group members. So these downstream people, these are not in the group, so you can cut it off. Okay, just prune it off, cut it off. Okay, and the shared tree, it is nothing but so all the group people they are sharing the same tree. That way we are going to call it as the shared tree. So the Steiner, we can also call it as the Steiner tree. So minimum cost tree connecting all the routers with attached group members. Okay, so means the tree can be shared by all the group members. Okay, with the minimum cost tree, where they are going to collect all the routers in the tree attached to the group members. And here there is one issue. Okay, so the issue is NP incomplete, means this is not that efficient algorithm, so that's why it is called as the problem. In the problem is NP complete, and here we have the excellent heuristic exists here, but it is not practically it is not possible. So, and one more thing, computational complexity is there, and their information about entire network is required, and this is monolithic. So rerun whenever a routers needs to join or leave. So this is said to be the tree, the shared tree. So suppose if anyone leaves or anyone adds to the tree, so at that time what you have to do is you have to rerun the complete tree. So that's why there is a drawback here. And center based tree, so already we have seen the center based tree is nothing but so single delivery tree shared by all, where one router identified as center of the tree. So as we have seen, a center node will be identified, and then we are going to do the broadcasting or multicasting, okay, depending upon the spanning or the shortest path that is existing. Okay, so that's why it is called as a center based tree. Means in the tree you're going to identify one router or a one node as a center node, and from there you're going to start broadcasting. Okay, so to join, so overall the group members who are there, so they are going to send a join message. So edge router sends unicast join message address to the center router. So who are the routers that is existing, so they will be sending the unicast join message. Then the join message will be processed by the intermediate routers and forwarded towards the center. So usually the intermediate routers, what they're going to do, they're going to process whether the center node is reachable from that particular router or not. So if from that particular node, if it is reachable, then they're going to process and they're going to move that packet to the, means move the join message to the center by connecting to the center node. Okay. Join message either hits existing tree branch for the center or arrives at the center. Join message either hits the existing tree branch for the center or arrives at the center. So join message, they can hit the existing tree branch for the center or arrives at, they can directly come and contact the center node, or suppose if any intermediate nodes exist or if any tree branch exists, okay, where that will be connecting to the center, and if there is no any direct link, so at that time it can come through any other tree branch or it can directly contact the center node. Okay. Path taken by the join message becomes new branch of tree for this router. So whatever the path taken by this join message, so it will be new path or a new branch for the tree to the router. Okay, that's how the center based tree that will be constructed. So here you can see. Okay, suppose if so here now the one, it's going to send a message. Now let us consider if R6. Suppose R6 it is chosen as the center, where it may be reachable to all other nodes. So now at the edge nodes, what it's going to do, it's going to send a message to the router. Suppose if it is at the center and it's directly connected, it can directly send a message to R6, or else it has to send through other intermediate routers. So R3. From R3, there is an existing path directly to the center node called as R6, and from R4 through R5, the path exists. This is the second path. And the third node R1, it's going to send a message to the center node that the path is existing. So like this is indicated as the count. So R1 and even R2, it can send a message now. Even there is a path that is existing from R4, but here only there is 4 group members, that is R3, R6, R4 and R1. Only to these people the message should be reachable and the path should be constructed. So that's why a path is established here in order to do the multicasting to a group of people. In this network, actually 7 routers are there, but only 4 routers form a group. That is R3, R6, R4 and R1. But R5 it doesn't exist, but this is an intermediate router. In order to reach R6, so R4 has to cross the router called as R5. But this is not a group member. It doesn't belongs to the group member. Okay, so R1 to R3, R1 to R4, this is one path, R4 to R6, another path, and R3 to R1. So this 1, 2, 3, this indicates the count, the path order in which they're going to join this particular routers. Okay, so the distance vector multicast routing, and under this we are going to study the sparse based and all. So that one we are going to study in the tomorrow's class. So as of now, so we have discussed about, so that is the spanning tree, and then flooding concept we have seen, and then the shortest path tree, the multicasting, the broadcasting, how the spanning tree will be created, so how the flooding can be controlled. Okay, so here we have the broadcasting, how the duplication of packets will be generated while broadcasting, how we can avoid that, and flooding will be one problem where it leads to cycles and the broadcast term. So the control flooding should be there, so that can be achieved either by packet ID, specifying the packet ID, or reverse path forwarding mechanism, and the spanning tree mechanism. So spanning tree has to be constructed, that is nothing but the shortest path tree. You can choose any of the node in order to construct a spanning tree. But the thing is, all the nodes should be covered with the shortest path, so that one we can also call it as the minimum cost or least cost spanning tree. Okay, and this is the path that shows how the spanning tree will be constructed and the order in which the spanning tree will be constructed. We have seen the tree, shared tree, and the source based tree. So where there is two approaches for multicast, building the multicast trees. One is source based and other one is the group based. And we have seen how to construct the shortest path tree using the Dijkstra's algorithm and reverse path forwarding. So reverse path forwarding. So that is, we have to see that while delivering the packets, we should not deliver to the node from which you have received. That is one condition. And second condition is, so you have to deliver the packet only if the router or the node that is existing in the shortest path, unicast shortest path, or else the packet has to be rejected. Okay, so reverse path forwarding. In the reverse path forwarding, why the pruning has to be done? Suppose if the people or a group of people that doesn't belong, then you have to cut off those routers. So that is called as the pruning concept. Okay, we have seen the shared tree. Shared tree, it cannot be implemented practically. It is very complex to implement, and we have a problem with respect to this NP completeness. So that's why it cannot be implemented practical. And center-based trees, where you're going to choose the center node, and each and every node that is existing at the edges, they are going to send the join messages. They can join the center node directly or through the intermediate routers. Okay, this is center-based trees, and this DVMRP, that is distance vector multicast routing protocol. So we are going to study in the next class. In the next class, we'll complete this third module, and from next we'll start the fifth module. Okay, and fourth module we'll do the POGIL activity, and also we'll cover the concepts. Thank you, students.